Hello, Geometry. Chapter 4, Lesson 3, this is rotations. We've done translations and reflections. Rotations is the third of what they call the rigid transformations. It's the third one where the shape stays the same as we rotate it around. And so the question here, how can you rotate a figure in the coordinate plane? That was it for that sheet. We're going to do, that was on page 102. And we're going to jump ahead to our vocabulary here on page 104. Okay. Rotation. Let's go back. Rotation is going to be a transformation where a figure is turned around a fixed point. Okay, a transformation where a figure is turned around a fixed point. That fixed point is called the center of rotation. This is the name given to the fixed point. Name given to the fixed point. Okay, that's called the center of rotation. Okay, so think of a fan is the hub right there in the middle of the fan. That would be the center of rotation. The angle of rotation. This is the angle formed from the vertices of a pre-image to the center of rotation and then to the image. Okay, angle formed from the vertices of a pre-image to the center of rotation and then to the image. So if you look down here a little bit with rotations, this right here, that is your angle of rotation. So this was point Q. We have two shapes here. These lines going from Q to P are not part of the shape. Okay, we have a flag. So Q, if you draw a line from Q to P and then from P to Q prime, that is your angle of rotation. And that should stay the same no matter if you're measuring it from Q or if I draw things on here from R. So if I draw a line from R to P and then from P to R prime, that should also be 40 degrees. So that measurement should be congruent to that measurement. Okay, so no matter what points you use, it always should be the same there. The final two, rotational symmetry. This is just when it's kind of like a line of like reflection symmetry. Rotational symmetry is when a figure can be rotated less than 360 degrees and the official word here is be mapped onto itself. Basically, it looks the same. Okay, it looks the same. So like a square. A square has rotational symmetry. So if you draw a square, you can rotate it 90 degrees and it looks the same. So it has rotational symmetry. Okay, the center of symmetry, that is the center of the rotation. Kind of, just think of center of rotation. This would have 3-4 lines of rotational symmetry. Okay, we'll talk about that here in a little bit. Okay, so what I want to start with here, talked about this already, is on grid paper here, I have a triangle, and I want to rotate 140 degrees counterclockwise with the rotation. This, if you look in your journal here, what we're following are these steps right here. Okay, same sort of deal, different shaped triangle. We're going to draw a segment from P to A, so we're going to draw a segment from the vertex to the point. We're going to draw a ray to form a 100-degree angle, 120, we'll do 140. We're going to measure it, so I have to measure it, and then we'll repeat the steps for all of them. Okay, so this gets into measuring, having rulers, making sure we are precise with what we're doing here. But I'm going to draw from A to P. Okay, I'm going to draw that segment. I want to measure 140 degrees. So I'm going to put my crosshairs right on that vertex. This line should line up with that, right, going along there. And I'm opening right, so I want to use my lower scale. I want to go to 140. Okay, so that's going to be my 140 degree angle. Now I need a ruler. I'm going to measure this. This seems to be about 2 1/8 inch. Get some practice with your measuring. And I'm going to make mine this long. And then this point over here, at the end of this should be A prime. Okay, there we go. Let me pull that down so you can see that again. Okay, so I drew this segment, A to P. I measured 140 degrees. And then I measured out here to make sure it's the same length, and I put my point up there. Okay, I'm going to do the same thing, B to P. This is going to be a shorter one here. So B to P, measure out 140 degrees, make sure this is lined up. Don't just say that's good enough, actually do a good job with it. Measure it. If it helps, you can measure it in the metric system. So that's about 3 centimeters. I'm going to line this up. So notice 3 centimeters is too long out there, so I'm going to put it at 6. Or I can just turn it around here like this. Line that up along there. I'm going to go 3 centimeters. And right there, that should be B prime. So we know we can connect A and B. A and B. Okay, now this is not our triangle. Remember these blue lines, darker lines here, they are helping me get the rotation done. Okay, finally, let's do C. Draw from C to P. I'm going to measure 140 degrees. Okay. This is about 6.1 centimeters. I'm going to put 0 on this point of rotation. Line that up. Go to 6.1. At the end there should be that should be C prime. So there's A to C. Okay. So we rotated that 140 degrees counterclockwise around the point P. Okay, so that's the sequence you use for that. Now, when we get to the coordinate plane, there are certain rules that we can use, and this will be a lot of our assignment here. We'll be using these rules here. But for rotation, make sure you keep track of these. For rotation, if we have AB, then it's going to be the opposite of B, A. So let's say we do a 90-degree rotation. If I have a point of -3, 4, if I apply a 90-degree rotation, that's going to switch the locations, and it's going to be the opposite of B. So this is like A, this is B, has to be the opposite of B, A. So opposite of B is -4, A would be -3. Okay, that's what happens with a 90-degree rotation. 80-degree rotation, you keep them in the same location, you just change their signs. So if I'm doing 180, if A is -3, 4, if I do a 180-degree rotation, A prime would be +3, -4. Okay, they just switch. And then 270-degree rotation, here's your kind of diagram over here. If A is -3, 4, The rule is they switch locations, and then the A this time is the opposite of it. So A prime would be, so that's A and B. We have to go to B, negative A. See how I write them down if I'm having trouble remembering which way to go? So it should be B, 4, opposite of A, positive 3. So negative 3, 4 should go to 4, 3. Here's that postulate that says a rotation is a rigid motion. That just means it keeps the same size and shape. Keeps the same size and shape. Okay, graph the image of the polygon after rotation given the number of degrees about the origin. That's what these rules are good for up here. These rules are about the origin. Okay, if you're going about a different point, you have to use the process we used at the beginning. Okay, so 180, so we're using the rule A, B goes to the opposite of A, opposite of B. Okay, so if J, we're counting by 2's here, if J is at negative 2, 4, J prime would be at 2, negative 4. So 2, negative 4. J prime. M looks to be at 1, 1. So M prime, we switch the A and the B, is going to be negative 1, negative 1. So right there, M prime. L is at negative 2, negative 2. That means L prime is going to be at positive 2, positive 2. You're starting to see the shape where this should be. K looks to be at negative 5, 1. So K prime, switch your signs. Negative 5 goes to positive 5. Positive 1 goes to negative 1. 5, negative 1. So see the labels I'm putting on there? And then you draw your shape. We have rotated that 180 degrees about the origin. Okay. Other thing to keep in mind is these are counterclockwise rotations. If you take advanced math, you'll see everything is counterclockwise. That is, a positive rotation is counterclockwise. A negative rotation goes clockwise. So I could do a 270 degree rotation, or I could do a negative 90 degree rotation. That'd be the same thing. Okay, we're rotating 90 degrees, again counterclockwise around the origin. So S looks to be at, we're counting by 2's, negative 1, 5. Our rule states for 90 degrees, I'm looking up here, AB is negative BA. So that's going to be negative B, negative 5, A, negative 1. Negative 5, negative 1. 5, negative 1. Okay, that's going to be S prime. Now if you draw those lines, you don't have to, but I just want to show this to you. Negative 5, negative 5, negative 1. That is not right. Negative 5, 2, 4, negative 5, negative 1. See, I drew those lines, and I'm like, that is not a 90 degree rotation. I caught myself there. So I draw that, and then if I draw this one over here, that looks like a 90 degree rotation. That should be S prime. We should switch colors now, because I messed that up. Okay, T. T looks to be at 2, 4, negative 5, 1. So T prime, opposite of B, negative 1, A, negative 5. Negative 1, negative 5. There's T prime, and again, I'm imagining, okay, if I go to the origin, then I go down to that looks about 90 degrees. R is at negative 4, 0. R prime, opposite of B would be 0, negative 4. There's our triangle, rotated 90 degrees, counterclockwise around the origin. Okay, 270. 270, the rule is A, B, goes who? B, negative A. Again, getting that from the top of the sheet. So A prime is going to be at, A is at 1, 4. A prime, B, negative A, so that's going to be 4, negative 1. 4, negative 1. There's A prime. B is at 2, 4, 4, 3. B prime is going to be, I have to look again, B negative A, so 3, negative 4. 3, negative 4. There's B prime. See how we're using these rules? C is at 3, 1. C prime is going to be at 1, negative 3. 1, negative 3. B negative A. So 1, negative 3. There's C prime, really tight in here. D finally is at 1, 2. D prime is going to be at 2, negative 1. Just notice how I'm labeling the points and write down all my work so I can get it done here. Okay, graph the image of Mn after the composition. Composition means you're doing two things. Okay, so we have a reflection in the x-axis followed by a rotation 180 degrees. So if you remember from the previous lesson, reflection in the x-axis, so you're going from one side of the x-axis to the other. AB is going to be go to A negative B, x-axis, sorry, my computer. I think it just locked me out. Am I still recording? Hopefully. Guess this is getting too long, huh? So AB goes to A negative B, and then after we do that, we'll go AB goes to opposite of A, opposite of B. So this is going to be a prime and a double prime. So if M is at negative 4, 4, when we do the first one, it's going to go to negative 4, negative 4. We're reflected in the x-axis, so there's M prime. And then it's going to go to 4, 4. Okay, there's the reflection around the origin. So I use this rule first, this rule second. So 4, 4 should be my double prime. So N is at negative 1, negative 2. I do the reflection in the x-axis, so that's going to be negative 1, 2. It's reflected up. There's N prime, so there's my reflection line segment. There's my reflection segment. And then I have to apply my 180 degree rotation, so that would be 1, negative 2. 1, negative 2. So there's N double prime. So if you rotate that 180 degrees around the origin, it's going to match up right there. Here we have a rotation followed by a translation. Starting to put all this stuff together here. So M, rotation, so that's AB, 90 degrees. Check it out. Negative BA. Negative BA. And then we're going to move it 2 to the right and 3 down. So M is at negative 2, negative 1. We're going to do the 90 degree rotation, so that's going to be 1, negative 2. That's the opposite of B, A. And now we have to do x plus 2. So x, that's 1 plus 2, which is 3. And y minus 3, so negative 2 minus 3 would be negative 5. Should use that in red. Okay, so my first point would be 1, negative 2. There's M prime. And then 3, negative 5. M double prime. Okay, 90 degrees about the origin for N. N is at 3, 1. We are going to do the rotation opposite of BA, so that is going to be negative 1, 3. And then we are taking negative 1 plus 2, so that's going to be 1. And then we'll take 3 minus 3, and that's going to be 0. So I'm applying the translation after that. Okay, so negative 1, 3. Negative 1, 3, is that right? Yep, that's blue. Negative 1, 3. So there's N prime. That looks to be the same size, same shape. That's a 90 degree rotation. And then the last point is at 1, 0. That's going to be right there. N double prime. Moved it 2 to the right, 3 down. As long as they look the same size, same shape, you should be okay with that. Okay, some more practice with this. For time, I know we're getting close here. I want to go look at, these are just going to follow all the same patterns that we've been doing. Okay? So here it's translation, then rotation, rotation, then a reflection. Now this reflection is over a line x equals 2. Remember, that is that line right there. Okay? So I'm going to skip that. Let's look down here. Determine whether the figure has rotational symmetry. If so, describe any rotations that map the figure onto itself. So we have a regular pentagon here, meaning all sides are the same length, all angles are the same. And this one would have rotational symmetry. Because if this is our center of rotation, if you think about it here, if I rotate it this amount, it's going to map back onto itself. So notice how each of these would map back onto itself. So I'd have this rotation, I have this rotation, and then this rotation. So I have 4 different ways. When I go, I'm not sure when my screen's going black. Oh, we're not plugged in. There we go. That would help. Notice there's 5 different ways, 5 different segments here. If I take 360 divided by 5, why 360? Okay, because one rotation has 360 degrees. 360 divided by 5 is going to be 72 degrees. So this first one is 72. The second one is 272, 2 times 72, so that's 144. That's 2 times 72. The third one, you have 72 plus 72 plus 72, that's 3 times 72. So that's 210 and 6, that's 216. And you have a fourth one here, which is 4 times those 72s. So that's 280 plus 8, so that's 288. Now if you do 5 72s, you're going to end up back at 360, which is where you started. So that's not a rotational symmetry. So those are the angles that would work for that regular pentagon. This one here, these 2 angles are the same, but there's no way to rotate it. You can imagine it rotating and going back onto itself. So this one has no rotational symmetry. Okay? So rotational symmetry, once you look at these examples here, identifying rotational symmetry. For a parallelogram, it says it does. The center is the intersection of the diagonals. And a 180-degree rotation about the center maps the parallelogram onto itself. Notice the wording there, 180-degree rotation about the center. This is a regular octagon, and it's going to have quite a few of them. It did not go over 180 though. So 45, 90, 135, 180. Okay, you can probably keep going if you wanted to. Trapezoid did not have rotational symmetry. So a rhombus would. You can spin it 180 degrees. This octagon would. You could do 90, 180, and 270. This right triangle would not. Okay? You can kind of think of a fan kind of spinning here. Okay, I should read this here. The figure can be mapped onto itself by rotation of 180 degrees or less, so we should not use those 270s. Okay, anything more than 180 you should not use, 180 degrees or less. Okay, that takes care of that. Good work. I'll see you in class. Sorry for the technical difficulties on this one.